All right, good morning. This morning we're going to be talking about factors. Okay, you're going to have to take some moments during this video to pause. For time's sake, I'm going to move on. So once in a while when I tell you to take something down, make sure you hit pause and you're able to take down these notes. All right, here's your first notes for this morning. Factors. Factors always go down. There are all the numbers that you can multiply to get a given number. For example, if you were given the number 12, the factors would be 1, 2, 3, 4, 6, and 12. Why? Because 1 times 12 is 12, 2 times 6 is 12, and 3 times 4 is 12. All right, make sure you hit pause and take these notes down. When you're ready, go ahead and continue. All right, I want to show you how to factor a couple of numbers. Number 12. If we want to write all the factors of 12, we could do this two ways. We could say 1 times 12, 2 times 6, and 3 times 4. Or you can list them 1 times 12, 2 times 6, and 3 times 4. A lot of people like to write the top way because it's easier to find the common factor when you do. But if you're having a hard time and you need to come up with them in the order that you can think of them, go ahead and do it this way. I usually recommend, though, that you start with 1. Does 1 times anything equal 12? Does 2 times anything equal 12? And you go all the way up until you run into the next number. What I mean by that is when I say, does 3 times 4 equal 12? Yes, it does. Well, 3 and 4 go right next to each other, so then you know you're done. Okay? Let's try 30. Well, 1 times 30 is 30. 2 times 15 is 30. 3 times 10 is 30. See, this is why this makes it a little difficult, because you start running out of room. Let's see, 4 times 7 is 28, so I know 4 more is not 30. How about 5 times 6? And then, now that these numbers are side by side, I know that I'm done. 5. I know 1 and 5 are factors. 2 times anything? No, because 2 times 2 is 4. 3 times anything? No, because 3 times 2 is 6. 4. So, if you have a number that's only 1 and 5, then you know that that number is prime. I like to think of prime as like a really strong guy who doesn't need anyone else but himself. Prime numbers only have multiples of them times themselves, and that's it. The rest of these are called composite numbers. Composite numbers have more than one multiple to make that number. So prime stands by itself, composite needs friends. All right, our objectives for today. Our objectives. You're going to be able to create factors of a number, you're going to create a factor tree, and you're going to create a factor foldable. All right, next we're going to be looking at how to make a factor foldable. Before we do that, I want you to get that foldable out, and if you don't have it, it's going to be uploaded on Schoology, and I want you to take a moment and fill in these notes. Okay, make sure that you pause right now to go ahead and take these notes down. When you're ready, go ahead and hit play and move on. All right, here is your second set. And I have one more picture to get this side over here, so if you can't get it right now, that's okay. Again, please pause, take the notes, and let me know when you're done, and we'll just hit play and move on. There's your last set of notes. Prime numbers and composite numbers. A prime has exactly 2 factors, 1 in itself. Composite, and it shows a factor tree on our notes. We'll get to that in just a moment. All right, now that you've gotten all your notes down, what you're going to do is you're going to go on the Schoology link, and you're going to hit play on the foldable. And if you can't find it, I'm going to play it for you right here, I hope. All right, get ready to make your foldable. I gotta fast forward here just a little bit. Here we go. All right. If you need to, again, pause so you can follow along. All right, that's all there is to it. That's a pretty simple foldable. We'll be doing more complicated ones later in the unit. All right, now we're going to practice some factor trees. Factor trees are what we use to create the greatest common factor, and we'll be doing that during this week. When we create factor trees, what we're going to do is we're going to break down these numbers into the smallest thing that we can think of. So, 18. If I think of 18, I'm going to try and think of the small. I like having prime numbers on the left side if I can. Okay? So for me, I would say 2 times 9. Okay? So 2 times 9 is 18. Well, is there anything we can multiply to get 9? Right, 3 times 3. And since 2 and 3 are prime numbers, we're done. I like to bring these numbers down and put them right here. And you'll understand why in a little bit when we do greatest common factor in our next lesson. All right, 28. Now, you could do 4 times 7. And let's do that. But let's flip it and let's put 7 over here because 7 is prime. And I'm going to go ahead and bring that down because I know that 7 is prime, so I can already bring him to the bottom. Now I have 4. I know that 2 times 2 is 4. And I know that 2 is a prime number as well. So I'm going to bring them down. What if we did 34? How about... Well, it's an even number. Let's see, 15 and 15 are 30. 16 and 16 are 32. How about 17 and 17? 17 and 17. Let's try it. 17 and 17 is 34. So 34 works. So let's do 2 times 17. And you know what? Both of those are prime. So we don't even need these at all. We can just bring down 2 times 17. And you're done with that problem. Again, if this seems to be going fast for you, please feel free to back up and watch it again so that you really understand how to make these. Tomorrow we're going to be doing greatest common factor, and you're going to really need to know how to do these before we move on. All right. The next set I put up here does not have the circles. If you feel better using the circles, you can do that. 22. There's not a lot that goes into 22, but I know because 2 is right here and it's an even number, I know at least 2 goes into it. So if you have to, you can look at a multiplication chart and you would see that 2 times 11 goes into 22. And that's going to be it. They're prime. So this would be your endings right here, 2 times 11. How about 40? Well, I know there's 4 times 10. You could do that. But I also know 5 times 8 makes 40, and 5 is a prime number. So I would use 5 and bring it down. Then I will break down the 8. Let's see. I know that 2 times 4 is 8. And I know that 2 is a prime number, so I would bring it down. And I know that 4 can break down to 2 times 2. And I would bring those down and you're done. You keep breaking down until all you have left is a prime number. 5, 2, 2, 2 are all prime numbers. Now, if that's too hard for you, you can do different multiplication problems. And I'll give you an example in number 16. 16, you could do 4 times 4. And if that's the only multiplication problem you know of 16, use it. It's fine. But I know that 4 can break down into what? What can multiply to make 4? Right, 2 times 2. And are those numbers prime? Yes, they are. So now you know you're done. So factor trees, you break them down until you have nothing left but a prime number. All right, remember our objective today is making those prime numbers. Okay? If you're still struggling, that's okay. We'll just do a quick check. Make sure you got it. If you got it, you're great to move on. If not, we'll keep working on them until you got it down. Okay? Remember, I can create factor trees. I can find the factors of a number, and I can create a foldable about numbers. That's your objectives for today, and you're doing a great job. All right. If you need more practice, here's a couple problems that you can try. I know that 4 times 12 is 48. Now, is there a 2 that goes into it? Yes. I could have done 2 times 24, but I didn't think of that problem. I thought of 4 times 12. And again, as long as you break it down to a prime number, it doesn't really matter. I do it with prime numbers on the left side because I think it leaves it cleaner, but do it the way it works for you. All right, 4 breaks down to what multiplication problem? Right, 2 times 2. And 12 breaks down into, well, we could do 3 times 4 or 2 times 6. Either one would work. So I'll do 2 times 6. And 6 breaks down to 2 times 3. And then I always bring these guys down so that I have them all lined up in a nice, neat way. All right, 4. What does 4 break down into? We've been over this a couple times up here. 4 breaks down to 2 times 2. Are they prime? Yes, they are. You are all done. All right, one more example. 15. What would make 15? If you said 3 times 5, you got it on the money. 3 times 5 is 15. That was a terrible 5. Sorry, guys. All right. This is about it for factor trees. If you have any questions, feel free to get a hold of me. Otherwise, I'm going to have you do some independent work on your own. Make sure you got this down. Want you to try these on your own and see how you come out. And this is what I want you to turn in when you're done. Or if you have any other questions, I want you to find me. All right? Have a great day. Make great choices. And feel good about yourself because you got factor trees down.